This one is probably the least complicated conic section because we are also pretty familiar with the shape of a parabola, since a quadratic function plots points in the shape of a parabola, but a parabola itself is technically a conic section shape. It just is also the shape of a quadratic function. By definition, a parabola is the set of all points in a plane that are equidistant from a fixed line called the directrix, say directrix, and a fixed point on the axis of symmetry called the focus. That is one foci. So in other shapes there was two focuses, which is plural, foci, but focus is the single one. Here's what I'm looking at. Obviously you can see you have the U-shaped parabola. This one's to the side, that's okay. But this line over here is your directrix, and the dot on the inside right here is the focus. That is what we're going to be equidistant from now, the focus and the directrix. Parabolas are used a lot in construction of satellites. This is the shape that bounces points into a fixed position called the focus. So if you've ever seen a satellite, they're usually like a bowl, and then they have like a little point at the end where a little arm is there. The point where that arm is the focus. So all of those rays that are coming into the satellite are going to bounce right back to that focus area. Let's talk about the standard form of these equations. So again, just like with the ellipse hyperbolas, we have two different shapes. If your focus is along the x-axis, meaning it looks like this is your focus, your formula is the top formula on this paper, y squared equal to 4px. If your focus is on the y-axis, you're going to have an up and down graph, up or down, and its equation is x squared equal to 4py. Now your directrix is related to these, that's the wrong color. Your directrix is related to this number p, as well as your focus is related to this number p. So the number p that's in the formula tells me, kind of like the A and the B and the C when it came to the ellipse and the hyperbola, how far from the single vertex, no longer a center, we're just using it as a vertex, how far from the vertex the focus and the directrix are, how far the focus and directrix are. But this time we're using the letter P instead of A, B, and C. Now, one thing I want to bring to your attention is that you can have this positive shape that looks like a C. That's when your p-value is positive. If the p-value happens to be negative, that means that your graph is going to flip and it's going to be a backwards C. That's not a hyperbola. Those are your two options, either positive or negative for your parabola. In the same way, for the p-value being positive, we have a happy parabola. That's a normal looking parabola for us. Or if we have a negative p-value, it will be a sad parabola. So in the same way this happened, left and right, up and down, for parabolas when we learned about quadratics, all of that stuff is still here. We have a vertex, a focus, a directrix. Way simpler equation to work with. The last thing we're going to use that helps us graph these functions is the latus rectum. The latus rectum of a parabola is the line segment that passes through the focus and is parallel to the directrix and has its endpoints on the parabola. If we're looking at this equation right here, this picture right here, here is the first latus rectum and here's the second. This is really helpful for figuring out how wide, air quotes, wide our parabola is, because it will give us additional points along our curve to play connect the dots with. The formula for either a vertical or a horizontal parabola for the latus rectum is the absolute value of 4p. Endpoints of the latus rectum are helpful in determining the parabola's width or how wide it should open. Again, width is in air quotes because they don't really have widths, but we can kind of think of them that way. So those are the main things we're going to be plotting here. We're going to be plotting the focus, the directrix, and the latus rectum so that we can make sure that we have our graph going the right direction. Can we try one? Here we go. We're going to find the focus and directrix of the parabola given by y squared equal to 12x and then graph the parabola. Here's what I know first. Because this says y squared instead of x squared, I know that we're either going to have a parabola that opens to the left or opens to the right. So those are my two options. I need to solve for p in the formula to be able to decide if it's going to open to the right or open to the left. So what I'm going to do is I'm going to rewrite down, especially here while we're learning, I'm going to write down the formula for the parabola, which is 4p times x. And then right underneath it, I'm going to write down the formula from this problem. Do you notice something about this? The y squareds and the x's are in the same spot. But do you see how this 4p is now 12? So if 4p is equal to 12, what is p? 3. 3 is a positive number, so our parabola is actually going to open to the right because our p is positive. We're not going to have an opening left parabola. Great. For the first few examples, we have not shifted this graph off of the origin. So just like when the center was at the origin, this equation or this shape doesn't have a center, but it has a vertex. We haven't moved the vertex off the origin just yet. But we can find the focus and the directrix because we have the value for p. For a sideways opening parabola, your focus is going to be moving to the left and to the right, which means you're going to add the p value, just p, not plus or minus p, to the x coordinate. So for us, that means the focus of this parabola is at 3, 0. For the directrix, the formula is for a side-to-side parabola is going to be x equal to some number. And that number is negative p, which means for us, x is going to be equal to negative 3, and that's our directrix. The only other thing that we need to plot this, and we can get all of the information first, is the lattice rectum. And the lattice rectum is always found by doing the absolute value of 4p. So for us, what is the absolute value of 4p? What's 4 times 3? And what's the absolute value of 12? 12, which means the length of the entire lattice rectum should be 12. That means 6 on one side, 6 on the other. Let me show you how this works. We're first going to plot the vertex. Boom, done. It's at 0, 0. We're then going to plot the focus, which is at 3, 0. We're then going to plot a dashed line to represent the directrix at negative 3. Here's what I know. I know that these are equidistant from the vertex. I took 3 steps to the right for the focus and 3 steps to the left for the directrix. That's good. The only other thing I need to draw this parabola is 2 more points on either side of the focus. But I know that because my lattice rectum is 12, that I should go 6 above and 6 below the focus to show the width of this parabola. That whole distance is 12. So halfway would be 6 up top, 6 on the bottom. And once you have that distance of 6, you can connect the dots from the vertex to the points that touched the lattice rectum, and boom, we're done. We have graphed our parabola y squared equal to 12x. So this conic section has a lot less going on for it, but it's pretty different because it doesn't use any A, B's, or C's, which either makes it different enough to be easy to remember or hard enough because it's different enough to remember. Before we ask any questions, can we just do one more example? Because I think one more example will get the juices flowing. We'll be able to see a little bit better. Let's find the focus and directrix of this parabola and then graph the parabola. Now, because we see that this equation is x squared equal to negative 8y, my options are going to be a happy parabola or a sad parabola. We won't know which one it is until we find the value of p. Following the same steps I did before, if I write down the regular textbook equation of a parabola, and then I write down the version I have, I see that I can solve for p if I set up the equation 4p equal to negative 8. I missed my negative sign. Therefore, what is P equal to? -2. Are we going to have a happy parabola or a sad parabola? Sad parabola. So we know it should be opening down. Okay. We already have enough information to get started. Because we don't have any numbers added or subtracted to x or y, my vertex is going to be 0, 0. For the focus, this time, since we have an up and down parabola, we're not going to put the number for the focus, the p-value, on the x-coordinate. We're going to put it on the y-coordinate, which means our focus is at 0, -2. Because this is an up and down parabola, the directrix has to be outside of it and not touching, which means it needs to be a flat line. So instead of using x equal to -p, this time we're using y equal to -p. So for us, if we plug in -2, what is -2? +2. So our directrix equation is y equal to 2. The last piece we need is the LR, the lattice rectum. If we find that, we know that that formula is absolute value of 4p. So for us, the absolute value of 4 times -2, well, 4 times -2 is -8. And absolute value of -8 is 8. So our parabola should open up 8 spaces, 4 above the focus, 4 below the focus, for a grand total of 8. 4p? Yes. So if we plot these things, we're going to have our vertex, kind of like the center, at 0, 0. We'll have a focus at 0, -2, and a directrix that is at 2. Our focus should end up inside the parabola, and our directrix should end up outside the parabola. The last thing we need is the correct distance for the lattice rectum, which is 8. So I'm going to go to the focus and make sure there's a line that's 8 units long centered at the focus, which means I need to go 4 to the right and 4 to the left for a grand total of 8. And that goes through the focus, not the vertex. Once I have those 2 points, boom, you can plot your parabola. Okay, now that you've seen 2 examples, do you have some questions for me?
Do you have whiteout?
I do not have whiteout. I actually ran out the other day and I have not replaced it.
I have a off-topic question.
Sure. Okay, so question, what if this time I'm giving you the picture and I want the equation of the parabola? Can we handle it?
No.
Yes, we can. Okay, so it says find the standard form of an equation with a parabola with a focus at 5, 0 and a directrix at x equal to -5, and it is shown for us on the right. Showing this on the right, what is the coordinate point of the vertex for this parabola?
Wait, what? 0,
0,
0.
0. The vertex of the parabola is at 0, 0. So that's important for us because later it won't always be at 0, 0. So we want to make sure we're checking in on that to begin with. Now, question, if the focus is at 5, 0 and the directrix is at -5, what is the value of P? Let me back up for a second. When we did these examples, we found out that P was 3. So if you notice, my focus and directrix is 3 units away from the vertex.
P is 5.
So P is going to be 5. Same thing happens here because P was 2, or -2. So our P value is going to be equal to 5. Now we do need to check that this is a positive 5 instead of a -5. It's positive. Why is it positive? Correct. The directrix equals -p. So if the directrix is -5 and the focus is 5, that means P is a positive number. So it's the exact number you see in the focus, if that helps. Now, of course, we need to make sure we're using the correct formula here. Since this is an opening sideways, Since this is an opening sideways graph, I'm going to use the y squared equal to 4p times x situation. Because the up and down one is normal where it's y equal x squared, the side to side one is x equal y squared. So all I have to do is plug in the p-value here. So this is y squared equal to 4 times 5x, which if we just do that quick little math, this is going to be y squared equal to 20x. And boom. That's it. You can find what the value of p is, which from a graph is really easy. You just count. We'll be good to go. That's it. Now, of course, that's it for a while it's centered at the origin. If we start to move these parabolas off the origin, everything is going to shift by h and k. But we've already done this. This time h and k is just your vertex, it's not the center. But it does control everything the way the center controlled everything on the ellipse and the hyperbola. So the equation, if you have a center at h comma k, is going to be y minus k squared equal to 4px minus h. It's literally the same thing, just with the h and the k added and subtracted in there, just like before. Our vertex is at h and k. Let me highlight correctly. Our vertex is at h and k. Our focus is adding the p-value to the h for a sideways, and our directrix is subtracting the p-value from the h, again, for the sideways. So just like for our ellipses, whenever we had the regular formula and we wanted to shift it, we have to shift everything that involves x and y. We'll have to do the same thing for when we have a vertical axis of symmetry or opening up. So we have our vertex still at h and k. Our formula switches, but look, h and k still go with their respective letters. H is always with x, k is always with y. Hold on, there's some people in the hallway. Okay, the focus is found at h comma k plus p, which this time is above or below. So since it's above the vertex, we add it to the y value instead of the x value. And since the directrix has to keep up with that, we will again add and subtract that p value from k instead of from h, because it has to change the vertical value. But it works the same like it did for literally every other time we took a shape and moved it off of the origin. In fact, it might be a little simpler since this has less parts. Let's find the vertex, focus, and directrix for this parabola and then graph it. First things first, what kind of parabola are we going to have? Opens up or opens sideways? If we have x being squared, is that opening up and down or opening sideways? X being squared is kind of normal, right? Y being by itself, so it's either going to be an up or a down. Okay, if the y is squared, that's when it's side to side. Okay, so we know we're going to be using the formulas that will create, or the formulas for focus and directrix that have either a up or down axis of symmetry. Let's start with the easiest thing. What is the vertex here? Vertex is h comma k. What's the number that is added or subtracted to x right now? So the h coordinate is next to x, so this is 3, and then I think I heard it, -1. So h is with x, k is with y. Now, being that this is now something kind of crazy, we still find our p-value from this number right here. If this number is 8, that means that 4p is equal to 8. So what's p? 2. That's great, because now I have an equation that I can use to find the coordinate point of the focus. The focus for this parabola is going to be at h comma k plus p. Originally, it was just at 0 comma p, because we're moving this vertically up and down. When we shift it, we have to move it up and down from the vertex, not from the origin. So that means that my formula is going to be 3 and then -1 plus 2. Well, 3 comma -1 plus 2 is 3 comma 1. That is the focus for this parabola. The directrix, which should be outside, is again affecting the y value. That's what we're changing. So this is y equal to k minus p. And if we use our numbers, this is y equal to k minus p, negative 1 minus 2, which is y equal to negative 3. The only other thing we need to graph this parabola to make sure we have it wide enough is that latus rectum, and this part has not changed. Does not matter that we have shifted it because the width does not change, just the location does. So we're still going to do the absolute value of 4p, which for our numbers is the absolute value of 4 times 2. 4 times 2 is 8. What's the absolute value of 8? 8. So we know we have all of the pieces. We plot the vertex, we plot the focus, we graph the directrix. We use the latus rectum to tell me how wide to create this parabola. So we have a vertex at 3, negative 1. We have a focus at 3, 1. And a directrix at negative 3. I know from the focus, I need to be centered on that latus rectum, which means I need to be 8 units all the way across. How many on each side? 4. So 1, 2, 3, 4. 1, 2, 3, 4. That's where my other 2 points will be at 7, 1 and negative 1, 1. And once you have those points from the latus rectum, you can just go from the vertex through that point to create your nice looking parabola that is equidistant. Oop, that one wasn't great. You get it. That is equidistant from the focus and the directrix. No, that looks bad. I'm going to fix it. That looks better. Does it? Yeah, so the question was, for the vertex, did I just flip the signs? Remember that our formula itself has negative signs in it. So that means if you're plugging in a positive number, you still see the minus sign. But if you have a negative times a negative minus a minus, that makes a plus. So this is like plugging in y minus negative 1. So the k value is negative 1. So yes, in general, yeah, flip the sign. Other questions before we move on? We only got one more example. But guess what kind of example it is? It's fun. We're going to find the vertex focus directrix of a parabola given by, oh no, it's not in the correct format. We're going to have to complete the square. But only once. That's nice. Then we're going to graph the parabola. All right, let's work on completing the square because we need this to be in a format that looks like a standard form of a parabola. And right now, it really doesn't. We've got y squareds, we got y's, we got x's, we got plain numbers, we have 0. That's a whole lot going on. Here's what I want for us to do. I want to put all of the things that go together with the squared term, and in this case, it's a y squared, on one side. So I'm going to have y squared plus 2y plus something, which is going to be equal to that negative 12x plus 23, and then that magic number one more time. So if we look, I have taken the 12x and subtracted it to the other side, and taken this negative 23 and added it to the other side. And I've prepped, bless you, I've prepped myself to be ready to complete the square. To complete the square, just on one side, because I only need to do it for those squared terms. This is going to be 2 over 2 squared. 2 over 2 is 1. 1 squared is 1. Which means that the magic number in the boxes are both 1. The left side of this equation with the squareds it's really satisfying, right? It now factors immediately to y plus 1 squared. On the left side, if I combine all of that stuff together, I'd have negative 12x plus 24. We are so close to having this look like standard form for a parabola. But typically, I'm not going to have an x with a number in front of it. I'm going to have an x by itself inside of a parentheses. So that means I need to take the GCF of the right-hand side. What do negative 12 and 24 have in common? Yeah, we're going to make that negative, though, so that the x term becomes positive. Negative 12 over 12 is 1, so it's just x. 24 over negative 12 is negative 2. Oh, snap. This looks beautiful now. This is the standard form for a parabola, which unfortunately is not what I actually asked for in this question, but we need it to be able to answer the actual questions. If we were presented with this equation, where we didn't have to complete the square, first thing I want you to do is tell me what the vertex is. It is 2 comma negative 1, because the h comma k, h is next to x, k is next to y. Next thing we need is the p-value, but remember, 4p is what's multiplied in front of that parentheses with x, so 4p is equal to negative 12. And if that's the case, what's p equal to? Negative 3. That information is going to help me find the focus and directrix and latus rectum for this parabola. The focus, since this is a, actually, I don't know if I asked you this question. What kind of parabola is this? Does it open up and down or side to side? What's squared right now? The y. Is that normal or weird? That's weird, so it's side to side. Now specifically, since our p-value is negative 3, is it going to open to the left or open to the right? Since our p-value is negative, to the left. Yeah, the weird way, the flipped way. Great, so that means for me that we are going to adjust which variable, the x variable or the y variable, if we're trying to move and put a dot here. From the vertex, are we moving that left and right or up and down? So we're going to add or subtract the p-value horizontally. So we're going to, on this one, do h plus p, comma k. This time adding the p-value to the x term so that we're moving side to side. Which means we're doing 2 minus 3, comma, negative 1. And so for our numbers, that ends up being negative 1, comma, negative 1. The directrix, since this is a side-to-side parabola, is going to be an up and down line. So my directrix equation is x equal to h with an adjustment for p. So this is x equal to 2 minus 3. Minus negative 3, I should say. I did that in my notes myself. Because we're subtracting p, and p is negative. Well, negative negative is positive, so that means this ends up being x equal to 5. Last but not least, to make sure we can plot this correctly, we do need that lattice rectum length, which that formula does not change. It's the absolute value of 4p, which means we're doing the absolute value of 4 times negative 3. We've done this one already. 4 times negative 3 is negative 12, and the absolute value of negative 12 is 12. We have all the pieces we need. We can plot. What do I start with plotting? The vertex. So we're going to go to 2, comma, negative 1 and plot my vertex. The focus should be at negative 1, negative 1. Interesting. Our directrix should be at x equal to 5. I like to do a quick check at this moment before I get too far and get frustrated with myself. Would this open side to side if I was keeping the focus inside of it? Yes. Are the focus and the directrix the same distance away from the vertex? Yes. Those are my quick checks I like to do before I get frustrated. The lattice rectum length is 12, which means how many steps above the focus am I going to count? 6 steps above, and how many below? 6 below. 6 above and 6 below. So we have our other coordinate points of negative 1, comma, negative 7, and negative 1, comma, 5. Once we have those at the end of the LR, we can draw our parabola. So the hardest part with these parabolas is making sure you're using the correct formula for the focus and the directrix because they're so similar. Which one do you add the P to? Is it H or is it K? That's going to be the biggest hang up for you guys. So keep those formulas situated for yourself. Make sure you're understanding what you're adjusting to create these shapes.